Good morning. Today is April 6, 2020. And again, our subject is electronic equipment maintenance and repair. So this is teacher Ed. So batch 11. Good morning. And hope you get the correct answer for my first problem in resistance measurement troubleshooting technique. So for today, I am going to discuss with you the trouble that I introduced in my last video. So actually that is the first trouble. So here, as you can see here, this resistances indicates good reading. Okay, so this is good reading, meaning there is no trouble or problem with the circuit. So here. Okay, and upon introducing a trouble, so we found here that there is different reading, okay, between the first table and this one. So as you can see, there is a highlighted test point there, point CD. So and the reading is infinity, meaning it is a very high resistance. So at that point CD. And when you have like reading like this, meaning there is an open point between that particular test points. So let us try to check here. So as you can see here, this is the AC cord, this is the plug, AC cord, and we have here the switch. So from the diagram, you have here point C and D. So the problem is along this point, no? So there is a reading of infinity from point C to D. So from this point up to here. So actually, before you think of a complicated problem, so it's better to analyze simple trouble first. Okay, and make sure you understand what you are doing. So inside this plug, maybe you will not think that there is a protection here inside. Some AC or plug don't have, but in this case there is a protection here. So let's try to check it first here, no? You don't have to go further on this circuit. So let's try to open this AC plug. Okay. So as you can see here, there is a fuse here, and I put here an open fuse. That's why when you measure the resistance from this point up to this color brown, no? This color brown wire here, so the resistance is infinite, open, because of the fuse. But now I change it with a new one. So some important points here is you have to be particular with the rating of the fuse. So it is indicated here 13 amperes. So when you're going to replace with the new one, so it should be the same specification, because it is important for safety. Let's say for example, you replace with a fuse with a higher rating, maybe even though there is some short circuit, it will not blow easily. So it will create more damage to the circuit. Now, if you replace, for example, with a lower rating, when you plug the device, then it keeps again on blowing and blowing, and maybe you are thinking there is more problem. But because it is under rating, so when you plug this device, when you replace with the fuse with a lower rating, it will keep on blowing. So that's why it's important that you replace with the same rating, 13 ampere here. Let's say, for example, you replace with the same rating, and then when you plug the device, and then the fuse blows again. So that's the time you have to check for other problem. Maybe along this AC cord up to this point, there is a short circuit. So that's why it's important for you to analyze. Let's say when you replace with the fuse with the same rating, and then when you plug the device, again it keeps on blowing fuse. So meaning there is a problem along this AC cord. So you have to check this AC cord. So I hope you get the correct answer, and try to find out and practice troubleshooting using resistance measurement technique. It is important for you to practice, to improve and develop your skills. In my next video, I introduce the second trouble, and again try to analyze, and hope that you will get the right answer, and eventually you will learn something from this video. Good day again, Batch 11. Good luck and keep safe.